the portions of source code over which identifier definitions and declarations would be valid. Okay, we would say that the definition or a declaration of an identifier is visible within a certain portion of Pascal syntax. We have a main unit, okay, and that main unit declares an integer x. So that x is a global variable. It's declared inside the main unit, and so theoretically, if nobody else redefines it, everybody should be able to see that x. Okay, is that clear? Okay, all right. So if you want me to draw a little diagram here, we can do that. So we have main, and main defines x, okay? And then, inside main we have two procedures, think of procedures as functions, called A and B, okay? Now A is nested inside a main and also defines x again, okay? So now there are two variables that both have the same name x, okay? So, don't confuse the two. They're two different locations, but they happen to have the same name. And then A calls B, all right? Now B uses x, okay? And B is also nested inside main. So you have this kind of nesting structure. You have a main program, and inside main you have A and B, okay? The same situation would occur if this was a class and these were methods inside the class. If the class defined a field or variable, okay, called x, and then one of the functions or methods would also define an identifier called x. Yes?
So B uses the initial x, the first x?
Okay, that's where, I'm going to show you the difference. If you use static scope rules, okay, you have to look at, scope rules based on nesting of units within units. So this definition of x has effect between the definition of x all the way to the end of the main program, and therefore also theoretically over A and B, right? So when B uses x and you're using static scope rules, the ones based on nesting, okay, B will mean when B says x equal x plus 1, for instance, it will mean this x defined in main, okay? And you should understand that these rules are static, okay? Because the program structure doesn't change. Once you write the program, you compile it. That's the program structure, right? So you look at the program structure, you look at how units are nested inside each other, and you've got your scopes, all right? So you know that the scope of this x is main and B except for A, right? Because A provides an additional definition, okay? All right? Under dynamic scope rules, okay, a reference to a non-locally defined identifier like x, as far as B is concerned, B is using x, but B is not defining x or declaring it, right? So we say that x is a non-local identifier as far as B is concerned, okay? So B uses x but doesn't define it. If you're using dynamic scope rules, the place where the runtime system looks is in the context of the caller of that unit, okay? So who called B? A. Does A define x?
Yes.
Yeah. So if this language were to use dynamic scope rules, then the x defined in A would actually be invoked. It would actually be accessed and modified by this statement. Okay? And now, why do we call it dynamic? Why do you think we call this dynamic? Huh? How does it depend on the runtime? Is it possible that, at some point this x means this x defined here, and at some other time, it means a different x?
Yes.
How?
If there's some other function C which calls
Right. Okay, your colleague is right. Okay, suppose now that we have a third function C that also defines x and calls B. Okay, this time which x will be accessed? The one here or the new one in C?
C.
The new one in C. So you see that when you look at this statement, you actually don't know which location will be accessed. Okay, because it will depend on the dynamic behavior of a program. Who called who? All right. A called B, then it will be the x defined in A. C called B, then it will be the x defined in C. Okay, is that clear to everybody? Okay, any questions? All right. Again, let me remind you of the golden rule. There is no such thing as a stupid question. Okay, so don't be shy. All right. All right, so enough for scope rules. I should warn you that this is one of my favorite questions for the first quiz. Okay, all right? Okay, so make sure to read it in the book. Oh, by the way, the website for the course has been set up as of last night. Have you been able to access it? It should have all the information from last year. So the slides are slightly old, but in fact, I can't even show you my new slides because my computer will not be recognized by that projector. So, okay, all right. So download the slides, from the website. I periodically update them, so you should check them every so often. I usually post an announcement. And I should also warn you that there will be homework coming up next week. Okay, early next week, I'll post the homework. We'll probably be due in 1 week. So now let's talk a little bit about data types. Okay, I already asked for a definition of a data type from you, and you gave me a good one last time. Do you still remember what it is? Values. Yeah, exactly. A set of values. A data type is a set of values, right? Okay, so types can be associated with many things in programming languages. Two things that can be typed are either identifiers, that is to say names that appear in source code, or objects, that is to say things that exist at runtime, that have some memory space allocated to them. Okay, when we talk about the type of an identifier, we say that that's the kind of values that can be bound to that identifier. If an identifier is declared to be an integer, okay, we can only bind integer values to that identifier. That's the meaning of the word type of the identifier. The type of an object, on the other hand, is the type of values that can be stored with that object. Okay? So if an object represents an integer, you will only be able to represent integer values in that object. Okay? All right? Is that clear? Okay? Now, either way, the type will determine the kind of operations that you can apply to objects or to identifiers. So integer types will allow arithmetic operations, logarithmic, trigonometric, exponentiation, and so on, right? Okay. Strings will allow concatenation, change it to uppercase, lowercase, substring, and so on, right? Okay. So think of the type as essentially the values, and also think about the operations that come along with those values. Now, how do programming languages do data types? Kind of like they do scope rules, right? Okay, many languages have different kinds of scope rules, but they fall under the two categories of static scope rules and dynamic scope rules. And by the way, this was actually in the slide that I can't show you because I prepared it today. Do you know of any examples of languages that use static scope rules? Okay, the languages you used. What languages have you used so far? C, C++, Java. Do they look more like static scope or dynamic scope?
Static.
Static, right? So the overwhelming majority of programming languages actually use static scope rules, right? Does anybody know of a programming language that uses dynamic rules? Dynamic scope rules? I'll give you two. Lisp is one, and Perl is another. Okay? Perl is actually used more often than Lisp. Okay? So be careful when you use Perl. All right? Because the references to non-locally defined identifiers will be resolved dynamically in the context of the caller. Okay? All right? Now, for types, for data types, it's kind of the same scene. Okay? Practically no two languages have the same type system, but you can kind of broadly categorize them into two classes: static typing and dynamic typing. Okay? Static typing means that typing information is associated with identifiers. Okay? And that's the one that you're probably accustomed to, right? What do you think? C and C++ and Java, are they statically typed, in your opinion? Yeah, right? Because every time you declare or define an identifier, you have to say what data type it is, right? okay? Or when you declare a function prototype or a method, you have to say what the types of the parameters and the return value will be, right? So the typing information is associated with identifiers. Those identifiers live in the source code, right? And so they don't change because the source code doesn't change, okay? And so we call that type of typing system, static typing, okay? All right? So, you can declare, a variable to be an integer. This is the Pascal syntax. And then if you try to assign a string to that identifier, the compiler will refuse to compile your code. It will flag an error. So, you said, I was going to be an integer, and now you're trying to, bind a string to I. So forget it, okay? So typing information is associated with identifiers, not reference. All the values that can be bound to that identifier have to belong to the data type specified, okay? What is an advantage of, of this scheme? An advantage is that, the compiler can check and see if you might be doing something bad with the wrong values, okay? So look over here. I have declared I and j to be integers and k to be a character, okay? And now I'm adding I and j, and that's okay because the addition operation is well defined for integers. But then, I'm also trying to add I and k is a character, pretending that, this is not C, because, character is an integer type in C. I'm pretending that this is Pascal and not C, so this will be an illegal operation. You cannot add a character and an integer, and so the compiler can tell, because the compiler knows that k was declared to be a character and that I was declared to be an integer, and those two don't mix. Okay? So the compiler will flag an error and refuse to compile the code, and you'll have to fix it, and then you'll compile it. Okay? Is this good or bad? Do you like the idea that the compiler can do this for you? Yes. Why? Because you don't trust yourselves, right? I certainly don't. No, I don't trust myself. I have unlimited trust in all of you. Okay, sorry. Okay. So what kind of benefit does static typing give you in terms of, programmability? As a programmer, you're asked, to choose a language and say, I'm choosing this language because it's statically typed. Why?
Type checking.
Yeah, type checking, but what does it give you in terms of a benefit from the viewpoint of software engineering? Limit the errors. We call it reliability. It increases the chances that you will write correct code, right? Because certain kinds of errors will be caught by the compiler, right? Can you think of any other advantages? Yes.
Also, from a security perspective, if you specify, like for example, a field that should have a string and the user puts an integer or whatever, that could lead to.
Right. So the compiler, can also check, against, security threats. Right. There is another benefit. Okay. Reliability, security. What else? Okay. Let's hold off on the question.
Has typecasting something to do with this? Typecasting has something to do with this?
Yeah, typecasting obviously has something to do with this.
Okay.
Yeah, typecasting is basically a way of telling the compiler, forget it. I told you that I was an integer, but now I want to treat I as a real or a string, so forget what I told you earlier. Okay, that's what typecasting is. Okay, we'll get to it, when we cover C++. So let's look at dynamic typing, and then perhaps you will see another benefit of static typing. Under dynamic typing schemes, typing information is no longer associated with identifiers; it is associated with objects. Okay, so this is Smalltalk syntax. When you declare an identifier, you don't declare a data type for that identifier. You can bind any kind of object to that identifier. Okay, have you ever used a language like that before? No? Huh? Python, yes. JavaScript, does have a weak typing system. I think you can bypass it, but
SAS?
Huh? I don't know SAS, but anyway, Lisp and Smalltalk are dynamically typed languages. Okay, so this is perfectly legal in Smalltalk. You first assign the number 10 to identify an array, and then you assign. This is the syntax for arrays in Smalltalk. I can see the panic in your eyes. Yes, we will learn it, and it will not be as frightening as it is, as it looks now. This is an array with 3 elements. The first is a string that says first, the second is an integer number 2, and the third is a floating number 3.45. Okay? All right? So, A can be bound to an integer, A can be bound to an array. The array can contain elements of different data types. Okay? That's dynamic typing. Okay? So it's very convenient because you don't have to worry, right? When you code, it's a good feature for rapid prototyping languages because they let you code a lot fast, right? Okay, you don't have to worry about the operation in the runtime, right? And now the compiler doesn't do it anymore, so you have to do it at runtime. Every time you do that multiplication, you have to do a check, right? And there is another penalty at runtime. You have to store the typing information, right? So that takes space, right? So you lose time and you lose space, right? Okay? All right. Okay, is that clear to everybody? Any questions?
Professor, you said it takes space. How do we get to store it? And
How is it done typically?
yes.
It's done differently in different programming languages. Some programming languages have a tag, so-called tag, that indicates what the data type of an identifier is, broadly classified. And in the case of Smalltalk, there is a small tag. It's only 2 bits. It tells you whether it's an integer versus a pointer versus some kind of symbolic value. And also, there is runtime. The runtime system keeps type objects around. Keeps class objects. So every instance of a given class will have a pointer to the corresponding class object. So by following the pointer, the class pointer, you'll always find out, what type of an object it is. So, the storage structure, we're getting a little ahead of ourselves, but, every time you create a class, there will be an object associated with that class. And every time you create an instance of that class, okay, like, you have the string hello and the string, I don't know, there, okay? These objects will have a pointer to the corresponding class object. So if you follow that pointer, you find out what class it is. Okay?
It's going to be stored anyway, even if there's going to be a runtime error, it's not going to be a runtime.
Oh, you don't have to store this information, in a statically typed language, right? The dynamically typed language you do have to, right? Then there are languages that are not typed at all, like assembly language, where the information about typing is not associated, not stored anywhere, not with identifiers and not with the objects themselves. It's the programmer's responsibility, to make sure the right operations are applied to the right objects. We don't use assembly languages very often, right?
In this case, we store x equal to 10. In the next step, if I store x equal to some height, then how will be the, the
Oh,
storage?
there will be storage for the identifier, and the identifier will have an address which will be addressed via the object. When you say x equal hello, x will store the address of hello. You will create hello if necessary, if it didn't exist before. Okay, and when you change the value, you make it point to there. You say equal there, then this is no longer going to be used unless there are other references, and they will be automatically reclaimed for you by the garbage collector. Okay. Any other questions? Okay. So, what do you think are the mutual advantages and disadvantages of static versus dynamic typing? Another favorite question of mine. So, advantages of static typing: performance, right? Space performance, time performance, reliability, security.
Readability.
Yeah, you could argue for that, yes. Because if you know that the variable is going to be used, for a given, to store certain values, you can kind of make an educated guess as to what the variable will be used for. Yes. Okay. And for dynamic typing, flexibility, readability. No, flexibility, no readability. All right. We already saw what encapsulation is. It's the idea that you encapsulate, definitions together, and you only expose, the interface, and that's also the idea of abstraction. An abstract data type is a data type, that is to say, a set of values along with the operations that access and modify those values. Okay. Inheritance. What is inheritance? Well, it's defined there, but in case you've not used it before, it's the ability for you to define a class in terms of an existing class. We will see that the new class gets by default inherits, is set to inherit all the variables and all the methods that were defined in the existing class, which we call the superclass. Okay, right? How many of you have actually used inheritance before? About 2/3, maybe 3/4. Okay, very good. Polymorphism. Okay, let's see. Before I embarrass myself, is anybody here Greek or Greek descent or knowing Greek in any way? Okay. All right. So I'll try my best. Polymorphism means having many shapes in Greek. True or false?
I don't know Greek.
Oh, you don't know Greek?
Hard
Oh,
Greek.
okay, all right. Okay. Oh, I feel much better now. Okay. Thank you. It means having many shapes. Okay. There's many constructs that can have many shapes that can be interpreted in many different ways in programming languages. Identifiers can have polymorphisms. What do you think identifier polymorphisms refers to? How can identifier have many different shapes? Different data types, exactly. Identifier polymorphism, is either dynamic typing or static typing with some flexibility. Okay, all right. Another one is object polymorphism. An instance of a given class can be used, when an instance of that class is needed, or when an instance of a superclass. Say that you have a class person, okay, and person has a subclass student, okay, and now you need a person instance. Can you provide a student instance instead? Yes, exactly. An instance can be viewed as an instance of its own data type or of any of its supertypes, superclasses. Okay, all right. We will see more of that, as the course goes on. But for the time being, we'll just leave it at this. Overloading. Okay, that's another interesting definition. If you studied overloading, I don't know, in 340 or something like that. Yes. Okay. So overloading is the idea that the function or an operator can be applied to different kinds of arguments. You can supply different kinds of parameters. Okay. And the idea of overloading kind of happens only in statically typed languages because the compiler needs to know what operation to use. So it needs to know what the types of the operands are, and the only way it can know that is if the identifiers that appear, as arguments in the calls, have a well-known data type, and that's what happens in statically typed languages. That the identifiers do have data types. Okay. So overloading has been around for a long time because the plus operation, for instance, can mean integer addition or string concatenation in some languages, or matrix summation, or floating point addition, which is different from integer addition. The example I have in the next slide illustrates this point. These two pluses denote two different operations because in this case the operands are integers, right? A and B are integers, right? So this will be integer addition, which is compiled in a certain way. And here, you have y and z, which were declared as a floating point, double, to use C++ terminology. So this is a floating point addition. But you use the same symbol, you use the same name, right? So overloading is the ability for a programming language to define multiple units, functions, or operators, or procedures having the same name, okay? And different argument signatures, okay, or different parameter lists, okay? And so, in a statically typed language, the compiler can look at the operands, okay? A and B here, they're integer, okay? And so the compiler can decide which of the operations to apply in the case of a statically typed language. In a dynamically typed language, it doesn't make sense, right? Because the compiler wouldn't have a way of telling what kind of values these are. There is no typing information associated with identifiers in a dynamically typed language. Okay? You just say, A, B, and C are identifiers. You don't associate the data type with them. Okay? All right? Is that clear? All right? So overloading is something that is applicable to statically typed languages and is resolved at compile time. Okay? Now, an example of functions that or methods that are often overloaded are constructors, right? Have you used constructors in Java or in C++ before? Yes? Okay. Is it typical for a class to have more than one constructor? Yes. What is that? Overloading, right? Okay? You have, a constructor is a method, right? Okay? So you have many methods having the same name, right? How are they distinguished from each other? Okay? So the parameter lists. How does the compiler know which one to invoke each time? It looks at the argument list and it matches them, to the parameter list, and then it chooses the appropriate one. Okay? Right? Is that clear? Okay. All right. So the definition of an object-oriented language. Okay. An object-oriented language is one that lets you define directly abstract data types, that lets you put together values and their operations. Okay. They have to be kind of packaged together. All right. Values and operations. Okay. Does that remind you of anything? Classes, exactly, right? That's the first thing that you know how to use, right? To define an abstract data type, right? But not only that, an object-oriented language has to support inheritance. Okay? All right? There are languages that have classes or things that look like classes, but do not have inheritance. Okay? Those are not object-oriented. Those are said to be object-based languages. Okay? So somebody says, there's an object-based language. Okay? You know that you can put together operations and value definitions in constructs, and perhaps, those packages are classes that you can use to, as data type identifiers. Okay, in some cases you can. All right, but it's not necessary for that, for an object-based language. But basically, an object-oriented language has to have classes. Each class, the identifier of each class can be used as a data type. So if you define a class person, you can define identifiers of class person or create new instances of class person. All right? And it has to support inheritance. That's what it means for a language to be object-oriented. Okay? And it's not much. Okay. A little bit of a scare. Okay? I've had really bad experiences with my morning class across the hall, and being unable to get presentations going. All right, so the model of computation of an object-oriented program is different from the model of computation of a traditional program. Okay, for those of you who learn C, right? C is not object-oriented; it doesn't have classes. So in a traditional program, you have a main program, right, or a main function, and that calls other functions, and then they return, right? In an object-oriented setting, you have objects. Everything revolves around objects. Execution starts by sending a message to an object, okay? And then objects, perform computations, and as they perform computations, they send messages to other objects, and those messages they receive. Those objects that receive those messages will execute methods in response. Okay, so it's a different model of computation, and the equivalence is kind of shown in this slide. Okay, whereas traditional programming languages have types, object-oriented languages have classes, whereas the traditional languages have functions, the object-oriented messages have methods. And whereas, the traditional languages of function calls, the object-oriented object-oriented languages have messages, okay? Do you know how a function is different from a method? No. Or how a function call is different from a message? No? Can you think of any differences?
Function needs to return something, but a method.
Method, may or may not return, same thing.
Method is loading for the class.
Yes, so method is associated with the class. What does that mean? Each method has to have an implicit argument, which is a receiver, right? Okay? A method is executed because an object receives a message. So there is an implicit argument. Each time you execute a method, okay, there is a receiver, an object that's executing that method. What is that called? Can you refer to the receiver of a message when you're writing the code for the method? This, right? This. Okay? Have you heard of an identifier called this? Okay? What does it denote? Huh? No, not the current class, the current object, the current instance that takes that message. Okay? So the method is executed because the object received the message, and if you want to refer to that same object, maybe you want to send another message to the same object, you call it by calling it this. Okay? All right? In small talk, it's called self. Perhaps is more intuitive. Okay? Same receiver, right? So that's one difference, right? Okay? Another difference between methods and messages, when you write the message expression, because you're writing a method and you want to send a message, you want to call a method in another object, okay? Can you find out at compile time what method will be executed? All right, let me give you an example, okay? Then we'll come back to this part of the presentation. Okay. All right, let's look at this code right here. Let's say that I have Is somebody lose, a glass case? Let's say that we have a class called geometric figure, okay? And this class has many subclasses, two of which are of interest. They're called circle and square. Okay? All right, so that's our inheritance hierarchy. All right? We define the class called geometric figure, and then we define the subclass called circle, and then we define the subclass called square. If you never define subclasses, there are ways that you can do that in object-oriented languages. Okay? In Java, you use the word extends. In C++, you use the derivation list, and so on. Right? Okay? So, identifier polymorphism tells us that if we have an identifier of class geometric figure, we can bind instances of circle or instances of square to that identifier. All right? And that's possible in object-oriented languages. Okay? Or the flip side of it is, if you need a geometric figure, you can supply a circle or you can supply a square and everything will be fine. Okay? All right? So we could have conceivably this code. Okay? G1 is a geometric figure. Here I bind it to a square. Here I bind it to a circle. All right? Okay? Is that clear to everybody? It's legal, right? Even in a statically typed language. Okay? By identifier polymorphism. And then I send the message display to the object bound to G1. All right? Is it possible to determine at compile time which display method will be executed? No, why not? Right. We don't know, right? We don't know whether we have a circle or a square. If both classes redefine display, which it probably will, because a circle is probably displayed in a different way from a square. Okay? All right? The method that gets executed will depend on the class of the receiver. All right? We call this dynamic binding of messages and methods. Okay? And it's kind of a little, goofy for us because, we write the code and we don't know what method will be executed, right? Okay? But it's very powerful too. Okay? People love it. Okay? All right? Okay? Is this clear to everybody? Can you do this with functions and function calls? No. No. Whenever you call a function, you know exactly what function will be executed. There is no uncertainty. Here, the method being called depends on the class of the receiver. If this object is a circle, you'll execute, display defined in circle. If this is a square, you will execute a different, display method. Okay? All right? we call it dynamic binding of messages and methods because the message is bound to a different method, okay? And we also call it message polymorphism. The message is polymorphic. It could mean many different methods, okay? It will have many shapes, okay? All right? Whereas this is identifier polymorphism. The identifier can be bound to objects of different classes, okay? Right? Is that clear? Okay. Any questions? Going, gone. Let's go back to where we were. Okay, we were here. All right. This is something that you probably learned in 340, but it doesn't hurt to repeat, okay? Because my experience, enough students, didn't learn it in 340, and then end up explaining it other places, so better learn it once and for all. Okay, when the program is running, okay, so it's been compiled, maybe a few years ago. The object code has been stored on disk. You decided to run the program, so you brought, that file back into memory. You loaded it, and you loaded the runtime system for your programming language, and it starts running. Okay, your program will need space for its data, right? Variables that you declare, right? Objects that perhaps you allocate with new. All that needs to be stored somewhere, right? So there is a so-called address space that's associated with your running programs. Okay, this is actual logical memory that will be mapped to physical RAM when the program is running. Okay, and what I want to emphasize here is that your address space will be divided in general into 3 different portions. Okay. There is a so-called static space, there is a so-called runtime stack, and there is a so-called dynamic space or the runtime heap. Okay? So, static space is used for objects whose lifetime is indefinite. Okay? The entire program execution. What's the lifetime or extent of an object? It's a time. It's an interval of time during which the object exists. So objects with indefinite extent, how long do they exist? For the entire execution of a program. So there are some objects, like global objects that represent global variables, right, that have to exist for as long as the program runs. I gave you an example of one such variable last time. Okay, do you remember? Remember when I wrote function foo?
Static.
Right? Static, the magic word. Static int I. Okay? We're writing a function foo. We're declaring a local identifier, but we're declaring a static. What does that mean? That the value of I will be remembered across different invocations of foo. Right? Okay? So how does a runtime system produce that kind of memory performance? Okay? It keeps I around all the time. That's easy. Okay? So whenever a compiler sees this type of declaration inside a function, it will instruct the runtime system to make space for I here in static space. Okay? So I will be allocated for the entire duration of the program execution. Okay? All right? Is that clear to everybody? Static space doesn't mean you can't change the objects. You can assign I different values. I equal 3, I equal 5, and so on, right? It's different. Read-only space is also part of static space, but not all of static space. So I will be stored here, and it will take different values. But the idea is that I has to be around for the entire execution of the program, right? Even though, in this case, I is only visible inside foo, right? Okay? So the scope is only the function, but the extent is the entire execution of the program. And then there is the stack. All right, let's go slowly. Okay, so static space is allocated used for objects whose lifetime is the entire program execution. It's allocated before the program starts execution, and deallocated when the program execution terminates. Okay, whether it crashed or it completed successfully. Okay, what objects are allocated in static space in C and C++? Here are some examples. Okay? Objects define the file scope. Okay? All right? You know you can declare things, not inside a class or a function, right? You can just put them smack in the middle of a file or at the beginning of a file, right? Okay? In C and in C++, right? A little bit more enthusiasm? No? How many of you are familiar enough with C and C++ to know what a file scope identifier is? Okay, very few. Okay, all right. Well, let me tell you this. In C++, in C or in C++, in Java, typically things happen inside classes, right? But in C and in C++, you can have a file 1.c, for instance, and even before you have your main function, you could have, I don't know, a declaration not inside anything. This is called a file scope declaration or definition. In this case, it's a definition. Okay? So it will cause space to be allocated at runtime for this double floating point number x. Okay? All right? Okay? So this is a file scope definition.
What is the difference between file scope and global?
File scope is for global variables. Okay, this will be a global variable. It will be used also in other files if you want, as long as this was not declared static. So if you declare this static, then it's visible only inside the file that defines it, and no one else can get it. But if you don't define it static, it's still allocated in static space. Okay, but other files can use it as long as they redeclare it. They have to say extern double x, right? So they instruct the compiler that someone else will define the object. Okay, all right. Okay, any other questions? So this is what I mean by a file scope identifier in C and in C++. Okay, so objects define a file scope whether declared static or not. If they're declared static, you affect the scope, not the extent of the object. You affect the scope of the identifier only within the file that defines it. Class variables, okay? Variables in a class that you declare static. You can do that in Java too, right? Okay, those, what is the difference between a static and a non-static field in Java? But it's only one copy of a static field, right? A non-static field gets copied in every instance, right? But the static field exists in only one copy, right? Whether you have 0, 1, or 1,000,000 instances, but it's just one copy of a static field. And the static field exists even before you create any instances. Okay? All right? Where is the static field allocated, in your opinion? In static space. Why? Because it has to exist for the entire duration of a program. It has to be there even if you didn't create any instances, right? So that will go in static space. Objects bound to local identifiers declare static in a function. That's the example I had before. Okay? Because those objects have to retain their value across different invocations. Okay? Right? Is that clear to everybody? Any questions about this? Okay. Yes?
What about static and dynamic type languages? Like, if they use
Same thing. Like class variables, would be allocated in static space. The other thing that gets allocated in static space that's not data is code. Right, in C and C++, right, and that's read-only because you can't usually modify the code. Okay. All right. Any other questions? All right. Now let's talk about the second of the things that we saw. Okay, the runtime stack. And the book has a diagram similar to this one, but I think the stack is on top and the dynamic space is on bottom. It doesn't matter. Okay, it's just an abstract representation. All right, so don't get upset if my diagram is different from the book. Oops. Okay, so the runtime stack is used for objects that are allocated automatically. Okay, when are objects allocated automatically? Usually when you call a function. Okay, the function needs space, right? When you call a function, the function starts executing, what kind of space should the function require for its data? Yeah, I mean, the function could have local variables, right? Like, let's go back to our friend foo. Okay, so we had void foo, and we had that static integer, right? What do we call it, I or x? I, maybe? Do you remember? It was I? Okay, good, I feel good about my fading memory skills. And then, there is another variable j that's non-static. Okay? All right, so there is I static and j is non-static. What is the difference from a programmer's perspective?
Even before this method is instantiated, I would be allocated the space.
Yes. I stays around because it remembers its value between invocations of a function, whereas j is forgotten. Okay? So when the function is called, you don't need to keep j around all the time, right? Because it would be a waste of time and space, right? To keep j around all the time. You only need j when foo is executing, right? So when you call foo, you want to reserve space for j, okay? So, what about if foo has a parameter x? Where would you store x? In some space for foo again, right? When you call foo, you need to store x, right? Okay? And when the function returns, it also has to, the return value also has to be, recorded somewhere, right? Okay, so now think about the way functions call each other and return, all right? If function A calls function B, and function B calls function C, and function C calls function D, which one will return first? D. And which one will return next? And then B, and then A, right? So the order in which the functions return is the opposite of the order in which they were called. All right? Is there a data structure that lets you get things out in the opposite order in which you put them in? A stack, right? So why do we use a stack for functions? Because it's the obvious thing to do, right? So that's why we have a stack, and we call it a runtime stack. All right? What do we store in the runtime stack? Things that functions need when they're called. Okay? All right? Why do we call these automatic allocations? Because they happen magically for us. We don't have to worry about telling the runtime system, hey, reserve space for this. Okay? It just happens. Okay? When the function returns, what do you think will happen? The stack gets popped, and you move on to the function below, right? Okay? So when I use, I will use the name stack frame. Okay, I'll use the name stack frame to denote all the allocations pertaining to one invocation of a given function. Okay, so say that you have a function. This is how you also support recursive invocations of functions, like a function factorial, right? Could be defined in factorial of I could be defined in terms of factorial of I minus 1, right? Okay, recursively. So you could have a stack frame for factorial of 3, okay, that stores the number 3, and that calls factorial of 2, that stores the number 2 in another stack frame, and that calls factorial of 1 in another stack frame, and that probably will return, right? Okay, it won't do another recursive invocation. But basically, a stack frame pertains to one particular invocation of a given function, right? Okay, if A calls B, calls C, calls D, you'll have a stack frame for D with all the local variables for D, all the parameters for D, and so on, right? Okay? And below that, there will be a stack frame for C, and below that, there will be a stack frame for B, and below that, there will be a stack frame for A. Okay, is that clear to everybody? Okay. It's a new space automatically. In a non-garbage collected language like C and C++, you have to use free or delete to release the memory that's no longer used. Okay? So what are the advantages and the disadvantages of garbage collection? Okay? Well, the advantage is convenience. Okay, let's face it, you're spoiled. Okay? Okay? You never had to use free or delete unless, except for those of you whose primary language is C or C++, right? Okay? All right? So it's nice. It's very convenient. That's why they put it in Java, right? To make our job easier. Okay? Unfortunately, it makes it a little tougher to learn computer science, because as computer scientists, you need to learn all these things. Even if you're using a non-garbage collector language, okay, you have to know, I mean, this is your trade, right? You know, you're experts on programming, right? Okay, so you need to learn it, okay? It makes, you know, Java makes it a little hard, you know, to teach, because, you know, you don't have to do it in Java, right? So, very convenient, very nice. The big disadvantage is that in some runtime systems, okay, the garbage collector works by basically forgetting that, you know, there is space unused around until it runs out of space, okay? So all these objects stay around for a long time, except that at some point, you know, you ask, you know, for a new object, and there is no space left. Okay, so the runtime system says, okay, it's time to collect garbage. Okay, so execution halts. Okay, when I was working on the Lisp system many years ago, you could basically go out to lunch. Well, no, actually, it wasn't that bad. It was only 16 minutes. Okay, on my system. Okay. And then, you know, you collect all the garbage, and then you could start working again, all right? During that time, the system was not doing anything but collecting garbage, okay? And so, if you have deployed an aircraft navigation system, okay, that is, you know, tasked with keeping an aircraft on course and avoid colliding with a mountain, okay, or other objects, okay, this is not a very good idea for the system to go out for lunch, you know, for an indeterminate period of time, right? Okay, so people don't use Java, okay, you know, for safety critical applications in many cases. Or if they're using safety critical applications, they make sure that they don't create objects that need to be reclaimed, so that the garbage collector is not tripped. Okay, all right. So it's not suitable for time constraint or safety critical systems. That's why C and C++ are still the most popular languages of the day. Okay.
Is there a way in Java where we can explicitly free the memory?
I don't know, actually. Has somebody tried it?
It has a destroy command that automatically calls the garbage collector.
Yeah.
Yeah, of course. Yes, you can invoke, you know, the garbage collector automatically, but I don't think you can say, I want this particular object released.
So
Okay.
that will avoid, if there's something like that, we can avoid runtime errors.
Yeah, if it did that, yes.
Does the Dalvik cache?
Oh, well, that's different. Yes.
Does it have anything to do with automatic garbage?
Well, Dalvik is. Are you familiar with, you know, the concept of the JVM, the Java Virtual Machine?
Sort of.
Okay, it's a runtime system that runs, you know, Java programs, basically.
Yeah.
Okay, Dalvik is another runtime system that runs on Android devices that are, you know, power, you know, starved and energy constrained and all those things. Yes. Okay, so C and C++ are the most popular languages of the day still. Okay. Now I have 5 minutes, so I can finish explaining the disadvantages and the advantages of programmer controlled deallocation. The big advantage is efficient, okay? You have control over when objects get relinquished. When do they get relinquished? When you tell them, you know, to go away. When you delete them explicitly or free them, okay? Okay? So you know, there is no performance penalty in the sense of, you know, the system, you know, stopping what it's doing and, you know, going and garbage collecting. But there are a lot of disadvantages because knowing when to deallocate objects can be very tricky. It can be very tricky. In that example over there, it's obvious, right? You allocated something, it was in that context, and then, you know, you're leaving that context and you had to deallocate it. But in some cases, you have multiple pointers, right? If an object has multiple pointers, and you know that one of the pointers is going out of scope, you may not know whether it's appropriate to let this object go or not. If somebody else is using that object, you cannot deallocate it, right? Okay? There is aliasing, different ways of referring to the same object, right? In programming languages, okay? So what are the errors that you can make? Well, one we already saw is the memory leak. You forgot to deallocate the object. If a memory leak is in a loop and you keep, you know, leaking memory, eventually you'll run out of space and your program will crash. You know, segmentation fault, code dump. Have you ever seen that? Yes, of course, right? If you've done C and C++. All right? Okay, that's what happens. It's a very abrupt ending to your execution. And worse yet, you have no idea why your program crashed. Okay? You know that there is a memory leak somewhere. It could be anywhere in your program. Okay? So debugging, you know, this kind of error is extremely tedious and time-consuming. Okay? You know, you can have debugging tools that will help you, but if you don't have those debugging tools, you're just left with your source code and trying to decide where you are allocating some objects and you are not letting go of them can take days, okay? Then there is the dangling pointer, which is the opposite error, okay? You deallocated something that someone else was using, okay? All right? So you decided that this was no longer needed because you went out of scope, you deleted it, so this will probably get reallocated to something else, it will get overwritten, and then the poor pointers that are still pointing that space will see their data change under their nose without having done anything to that data, right? Another error that can cause a segmentation fault, core dump, the program crashes, and also very difficult to debug. Again, why? Because you have no idea where that deallocation happened. Okay, that was not supposed to happen. Okay, and then there is also another problem, which is multiple deallocations of the same space. Okay, something is going away, and the overzealous programmers decided to delete the same object multiple times. Sometimes, depending on how the free list or the heap is kept, this may be eligible for double allocations later on. Okay, maybe put in the free list twice. Okay, and so maybe allocated twice, to the same object. Very, very difficult, errors to find and to debug. So this is the reason why we like languages like Java that have garbage collection, because these things can't happen. Okay, with garbage collection. I made a big deal last time of pure versus hybrid object-oriented languages. I told you why I like teaching Smalltalk and C++. And I said Smalltalk is pure, C++ is hybrid. Smalltalk is statically typed, C++ is dynamically typed. Now this should make sense in the light of today's discussion. You understand the difference between static typing and dynamic typing. But the distinction between pure and hybrid, is explained here. In a hybrid language, in a pure language, every type is a class. So there is no data types except for classes, and every function is a method. Okay, not a standalone function. Every function call is a message. Every expression is a message expression, and the program execution is usually started by sending a message to an appropriate object. Okay, so that's the pure, pure object-oriented language. Essentially only embody the object-oriented paradigm and nothing else. In the case of hybrid languages, the object-oriented constructs coexist with traditional language constructs. So you can avoid using classes if you want, because you also have traditional functions and function calls and main units and all that. So C++ is hybrid because it incorporates C. You can write C code and compile it with a C++ compiler and call it C++ if you want, and that will be fine. Okay, Smalltalk is pure, Java is mostly pure. Okay, all right, so that's the difference. Okay, remember, it's an object-oriented language if it just has those features, classes, polymorphism and inheritance, and so a lot of languages that differ deeply with each other, can call themselves object-oriented. The purpose of this class is to expose you to the breadth of the spectrum of languages. I'll see you on Tuesday. Have a nice long weekend.